So, what on earth does a tiny piece of metal locked away in a vault in Paris have to do with living a better, more meaningful life? I know, it sounds like a stretch, but trust me, the incredible story of how we redefine the kilogram is one of the greatest examples of a powerful philosophy, the disciplined pursuit of less but better. At the heart of this is an idea called essentialism, and it's not about trying to do more. It's about making sure you're doing the right things. It's all about learning how to cut through the noise, to figure out what's truly vital and what's just trivial. So let me throw a kind of wild idea at you. The kilogram feels about as fundamental as it gets, right? It's literally the definition of mass. But what if the biggest leap forward for science wasn't to improve it, but to eliminate it completely? Okay, let's get into it. To really understand why scientists would even want to get rid of the kilogram, you first have to understand what it actually was. For more than 130 years, this was it. This little cylinder, nicknamed Le Grand K. Think about this. Every single measurement of mass on the entire planet, from the pills you take to the fuel in a rocket, was ultimately tied back to this one single object. The world's weight, quite literally, rested on this one artifact. But here's the thing, and it's a huge thing. Relying on a single physical object, no matter how carefully you guard it, creates a massive, and you might say, unessential problem. The standard of mass wasn't standard. That's the whole problem, right? Physical things change. Even this incredibly precious cylinder, over a century, Le Grand Croix was either picking up microscopic bits of dust from the air or losing atoms every time it was cleaned. It was like having a ruler that was constantly and unpredictably changing its length. Not good. And this created, well, a kind of chaos. See, the world had dozens of official copies of the kilogram, but over time they all started to drift apart from each other. When they checked them against the original, they were all off by about 50 micrograms, which, for perspective, is about the weight of a single eyelash. So which one was right? The original? The copies? The scary answer was nobody knew for sure. It was a total mess of measurement errors with no single source of truth. So this instability, this huge problem, it launched a global mission. The world's top scientists knew they had to find something truly essential, something that would never, ever change. And this was their essential goal. It was so simple, and yet so radical. They decided to get rid of the physical object altogether and tie the definition of mass to something woven into the very fabric of the universe itself. And they found it in this number, Planck's constant. Now, this isn't just some random value. It's a fundamental constant of quantum mechanics. It's the same here, it's the same at the edge of the universe, and it will be the same a billion years from now. This was the one vital thing they were looking for. So how do you connect a number to a weight? Well, this beautifully simple relationship is how. Scientists figured out they could link mass directly to Planck's constant by perfectly balancing electrical power with mechanical power. Essentially, they found a way to weigh an object using nothing but the fundamental laws of physics. No other objects needed. So, how did they actually do this? The machine that makes this magic happen is called a Kibble balance, and it is an absolute masterpiece of essentialist engineering. Building a Kibble balance is a masterclass in the art of saying no. To get a measurement precise enough, the engineers had to say no to every single possible source of error, every tiny variable that could mess things up. For example, take the magnet inside the machine. Neodymium magnets are super powerful, but they're also really sensitive to temperature changes. Samarium cobalt magnets, on the other hand, are less powerful, but they are incredibly stable. The designers made a classic essentialist trade-off. They said no to more power because what was truly essential was rock-solid stability. The way this balance works is pure genius. It runs in two modes. First, in weighing mode, it measures exactly how much electrical current it needs to create a force that perfectly balances a test mass. Then, in moving mode, it moves that exact same coil through the magnetic field and measures the voltage that gets created. And here is the truly brilliant part. All the really messy, tricky variables, like the exact strength of the magnetic field, they show up in the math for both modes. So when you combine the results, all of that non-essential junk just cancels itself out. The design itself systematically eliminates all the noise, leaving only the pure essential signal. So after decades of work from scientists all over the globe, what did we actually get?
What was the final, profound result of this incredible essentialist pursuit?
Well, look at the difference. We went from an old kilogram that was a single, decaying object in a vault to a new kilogram that is basically a universal recipe. It's not a thing anymore, it's an idea. It can be created by anyone with the right machine anywhere in the universe, and it's as stable and as constant as the laws of physics themselves. We traded one thing for one idea. We got rid of the non-essential to find the truly essential. That, right there, is the very definition of less but better.
This incredible scientific story is really a powerful metaphor, isn't it? Scientists had to say no to all that trivial stuff, the physical copies, the measurement drift, the noise, so they could say a huge yes to the one thing that truly mattered, a universal constant. And it leaves us with a pretty big question. What's the Lagrange K in our own lives? What's that one good but ultimately flawed thing we're clinging to that's keeping us from finding what is truly essential?